morning, good afternoon, and good evening. Welcome back to Chapter 18. We're talking about the mollusks. Remember, there's about 100,000 species of mollusks. There's a few different classes of mollusks we're going to talk about. Our first class of mollusks are the bivalves. There's about 20,000 species of bivalves, so about 20% of all mollusks are bivalves. Bi means two, valve means door. So they've got two doors, two shells. Clams and oysters. Clams and oysters are bivalves. They use their foot for digging themselves and anchoring themselves in the sand, and they're also sessile filter feeders. We talked about filter feeding when we talked about sponges. They draw in food, they filter that food, and then they eat. They draw in water, rather, excuse me. They draw in water, they filter that water, filter any floating bits and pieces, and they eat those floating bits and pieces. The interesting thing about how mollusks, how bivalves filter feed, is they actually pass the water through their gills. So the gills are pulling double duty. The gills are for oxygenating the blood, and the gills are for collecting food. They are the strainer for collecting the food. Kind of neat. Oh, what does sessile mean? It means non-mobile. It means they don't move around. Remember, we said one of the things about animals is they have to be mobile. They do move. They just don't move a lot. They can move, and they actually move quite a little bit as larvae, as babies. This is just a picture of mussels. You can see they're all slightly open because if they're a filter feeder, they need to draw the water in. Kind of an interesting thing about these animals is how they're built. They've got two siphons. So inside the animal, if this is my mollusk, they've got two siphons. The first siphon is for bringing water in. It's called the in-current siphon. Water comes in. It passes over those gills. Any kind of particulate matter, any floating stuff, is captured by the gills, and then the water flows back out again, the excurrent siphon. In-current siphon, water comes in, water passes over the gills, the water is pushed out the excurrent siphon. And if you look really close at this picture, one or two of them, you actually can clearly see the two open tubes. Those two open tubes, again, those are the two siphons. Right there, that's a great picture right there. Two open tubes, water comes in, water goes out. In-current, excurrent siphon. Phylum Mollusca, class Bivalvia, the bivalves. Here we see a giant clam. Giant clam are so-called giant because they're really big. A giant clam, most of them are about that big, though they can get to be this big. In this picture, I'm not sure if you can see it very well, but its flesh is very green. That's because they have a symbiotic algae that lives within their tissue, very similar to when we talked about lichens, how the algae live in the body of the fungus. The reason why these giant clams are able to get so giant is because, remember, filter feeding isn't terribly good. It's really cheap and easy, but if it's cheap and easy, it's because it's not very good. The reason why they're able to get so big is because of the symbiotic algae. The algae makes food for them, and they're able to get a lot more food and therefore grow a lot larger. And you can actually see the excurrent siphon right there. And a plate of oysters. You're eating the visceral mass and the foot. The visceral mass and the foot of the mollusk when you eat oysters. Our next group of mollusks are the gastropods, class Gastropoda. Remember, 20,000 species of bivalves, 80,000 species of gastropods. Class Gastropoda. Gastropods. Snails and slugs. Oh, snails, slugs, whelks, conchs, and abalone. It's pronounced conch. Patrick and SpongeBob did not have a magic conch. They had a magic conch. Can I have something to eat? No. Can I have something to eat? No. Do you say anything besides no? Yes. Can I have something to eat? No. Snails, slugs, whelks, conchs, and abalone. They are mostly marine. Let's talk about that word. What does marine mean? Marine does not just mean water. It specifically means salt water. If they live in water, they say, or rather you say they are aquatic. They are aquatic, but they specifically don't just live in any old water. They live in the ocean, and there are freshwater. Let me rephrase that. There are lots of freshwater gastropods. There's lots of terrestrial gastropods, snails and slugs, but most of them are marine. Most snails and slugs are marine. Nearly all are free living, and as we said, gastropods crawl with their foot. That loaf of bread looking thing that comes out underneath of it. Let's go back to the second to last statement, and where we say nearly all are free living. We've talked about this idea, this concept of what free living means before. It means they're not parasites. And so, yeah, snails and slugs, man, they're not parasites, right? Right, they're not. Almost all of them aren't. What does that mean? It means that almost all of them aren't parasites. Well, yes, but what does it imply? It implies that some are. It implies that there are some parasitic species of snails and slugs, and there are, in fact, parasitic snails. Now, don't worry about it. You're not going to get a parasitic snail if you go swimming in a pond somewhere. These parasitic snails are mostly marine. You ever been walking on the beach and you picked up a little clam shell that already had a hole drilled in it? Usually at that little bump, if that's a clam shell right there, there's a little bump. That little bump is called the umbo. It's not terribly important. That clam shell that you picked up that had a hole drilled in it already did not fall off of someone's bracelet or necklace. It was drilled by a parasitic snail. They used that radula, that toothed tongue, that rasp, to dig a hole, literally to drill a hole in the shell of the clam, and then they deposit an egg. The egg hatches, and the egg eats the clam from the inside out and then is released. Most snails are not parasites. Some are. Here we see some gastropods. This is a slug. Here is this is a conch. Right here. Magic conch. This is a slug. Those are both slugs. This does not look like any slug you've ever seen before. This is specifically a sea slug. And you might think, how am I supposed to tell the difference between that and one of those turbularians? Turbularians don't have any extensions coming off of them. They'll have folds like that, that's fine. But do you see how this clearly has antennae coming off of it? Do you see how it clearly has this bundle of gills in the back? That's how you know specifically you're looking at a sea slug. If you want to see some beautiful pictures, some gorgeous pictures, go do a Google image search for sea slug, or their proper name is nudibranch, nud-I branch, Nudibranch, nudibranch. Nudibranch literally means naked gill, nudibranch, naked gill. These are their naked gills right here. They've got those pretty gills sitting up there. How in the world can these things exist with these big waving things? Well, in those gills are nematocysts. You remember when we talked about those in jellies? We talked about cnidocytes, cnidoblasts in the jellies, how they're the stinging cells. Jellies are the only animals on the planet that make stinging cells. Well, wait a minute. You just said that these things have stinging cells. Yes, they do. Nudibranchs have stinging cells in their gills, but they didn't make them. They stole them. They stole them by eating anemones. Remember that mechanical trigger? the mechanical trigger should make it so that as soon as they go to bite the tentacle, it should pop off and they should get a mouthful of of nitoblasts. But they don't, and we don't know how. And then they pass those cnidocytes down into their stomach, where their stomach acid should dissolve the tissue around it. And also, acid will cause those nematocysts to go off to trigger. They have a chemical trigger and a physical trigger. The chemical trigger is acid. And they don't, and we don't know how. And then they pass those cnidocytes across the internal lining of their gut, and then pass them through up into their gills, and then they fill their gills with these nitoblasts. And so that if a fish, because fish love dangling, wagging things, right? Worms. A fish sees this, oh, that'd be a good snack, and they go and they take a bite out of the gills. You don't want somebody to eat your lungs. Well, they don't want something to eat their gills. And they get a mouthful of nitoblasts. And we don't really know how they do it. We don't know how they keep them alive. We don't know how they steal them. We don't know how they do this process. It's one of the mysteries of life.